Hello, everyone. So we'll start the invited talks now. Our first speaker is Dr. Nour Ghadban. She's from biomedical engineering here at Glasgow, and she'll talk today about advancing speech recognition for the hearing impaired, a multimodal radar approach in healthcare.
Thank you. First, I would like to say thank you for coming and welcome. My presentation, as Phil referred, that is in speech recognition and AI to support people who has hearing aids. Sorry. Okay. I will start by giving you the outlines of my presentation today. I will start with the context of my speech, and after that, I will speak about the research gap in this area and what is the novelty that the research applied in my research. And after that, I will say about the methodology. Then I will speak about the results and then finish with the conclusion. So there are levels of monitoring that can help with AI to make the health outcome is better. It comes from many different sensors like radar, like camera, like Wi-Fi, and these levels is macro level, which refers to large scale monitoring, which is best for daily activity. And also micro level, which is go through to details and more individual information. It is perfect for vital signs monitoring system. And also there's a type inference, which is drawing the conclusion and prediction. And the speech recognition is a very good example of this type, because from speech recognition, we can detect the health of the person. For example, it's Parkinson's diseases can we detect by speech recognition. And also we can maybe see the emotion for the people from speech recognition. So AI and speech recognition can be a type for healthcare inference for monitoring people. As I refer that we can collect our data from multiple sensors, Wi-Fi sensor, radar sensor, wearable devices, and also camera devices, and also lots of many sensors else. I want to refer that every sensor has positive and negative things. For speech recognition, I think all of you heard that we use audio to speech recognition to recognize the words. But we add visual also. But the camera has limitations, the privacy. All of us need the privacy. So we can use radar, who is excellent in a precise movement, and we can use it in this field. So, audio can detect what the people say, but if we have noise in this environment, how we can detect that? So we add visual features. But imagine if we have somebody who is sitting in a dark, maybe room, or wearing a mask. How can I detect these visual features? So our idea that we want to integrate audio features, visual features, and radar features to overcome all these limitations in audio and visual speech recognition systems, to make also the accuracy more better. Our idea is that we also want to support healthcare. How can we do that? So I see this article who is test people who have hearing issues. And these articles tell the people who has hearing issues that if we have noise, bubble noise, the people can't hear from under 15 decibel. So this is my idea, that to collect this data set and see how can audio and visual and radar support those people if we have maybe devices that can translate this word to these people. So we have 80 samples for different words: is to turn, doll, bite, make, sheep, long, and to talk. I collect this data from 4 individual persons, 3 women and 1 man. They are not native speakers, but they are fluent in English. And the duration for every word is 6 seconds. So our gap in research is how can use radar and also apply AI to make the accuracy and other metrics is better. So I will add the radar and also apply AI algorithms that can enhance accuracy, time training, and also another metrics I will refer into the next slide. We also, this is a specification of the radar and audio and visual that we use in our experiments. Why does it work? Okay. And this diagrams sees that work follow for the steps that we use it in our experiments. We start by pre-processing, and after that feature extraction, feature selection, training, and evaluate these experiments. I will start with the first step, the data processing. Now we deal with the features. So after extracting the features, we have to label these features because, as for example, everyone has name. So these names or these labels for features can make it the data is accurately interpreted of what I say or what happened. Also, I have data synchronizing. Data synchronizing because I have 3 sensors, and maybe sensors is delayed, and I have to align these time. So I have to find the timestamps and align these signals, and also this will ensure that we have the timeline, that we don't have misinterruptions in our training. And also, I make normalization, because if the features has numbers, not numbers, sorry, the scale is not same, so some features will be dominating another features. So I have to make it fair, so I have to make it normalization. So after I collect the data set, I start with the data processing, and after that I extract the features I use for visual, ResNet 15, for audio, MFCC, for radar, mobile visual net. I apply AI algorithms for feature selection, and I use the feature selection before integrated the features, and also after, to make the accuracy more better. And also I need the time, because the time is so important in real-time applications. So I use feature selection for audio, visual, ANOVA selection, radar CH squared test before the integrated, and also I use the SHAP for feature selection after the integrated. So this is the comparison of the numbers of the features that I have. So we see that audiovisual radar, before the selection and applying these features, it's 1,568. And it gives me better information when I use just only 500 features. And also for audiovisual and radar. Now I will go through something important that we don't see lots of in conference if we want to go deep in our network. So I built my network for input, layers, output. I will start with the model, visual, audio, and radar. I put the numbers of neurons and what the numbers of layers. And when I make some fusion for audio visual, I need embedding and flatter layer because we know that we have multiple dimension and I need to make it one dimension. And also for AVR, I add two hidden letters. So that's important if anyone wants to repeat these experiments. And also the batch size 32 epoch N. I evaluate our experiments using the training time that happen in our experiments, also inference time, the time that if we want in response for speech recognition, and also the size of the model and the accuracy. After feature selection, AI and radar, I have 87.2 for accuracy. And this accuracy, also, I want to refer something that radar by itself can act as audio and video. So it's important to know that radar is so important if we want to don't use audio and visual devices. So this is before and after feature selection, the accuracy. And this is the time. We see that we reduce the training time, inference time, and the model size is less when we use feature selection. Okay, now we have audio-visual radar system. We want to see if it's robust or not. If some features is deleted or removed by this system, what will happen? It will stop or not? Okay, and another thing, I want to evaluate the performance. Another thing, if I'm in real time or an environment, that means we have noise, some people speak, or maybe I have visual noise, or I have also radar noise. What will happen to my system? We evaluate these experiments by accuracy and also the sensitivity and the specificity, because sensitivity is that means to refer how positive predictions can the system detect, and also the specificity, the negative predictions. And so important for real-time application in speech recognition. We see that when we application the radar, the accuracy is so low. But when we application the audio, it will increase the sensitivity and the specificity a lot. So the radar is so important in the accuracy, but also the audio is so important in sensitivity and specificity. And when we apply the noise, when we apply the audio noise, we don't have the maximum accuracy until the 15 decibel. And if you remember, I told you that 15 decibel is so important in this article because people cannot hear these words. So audiovisual radar can make it in 10 decibel. So they can hear these words, not they hear. They can see these words and hear it by these devices. And if we apply the visual, also we can take the most accuracy from 10 decibel, but the accuracy different depend from audio or visual or radar. But the most important one is so effective for these systems is audio. Conclusion. So it's so important to know that AI and radar enhance the accuracy, training time, inference time, and model size. Radar can act as audio-visual speech recognition systems. Our audio-visual speech recognition system is robust, and also feature abolition is so important to see that this system how can act if any feature is removed. So we see that audio is important for sensitivity and also the radar for the accuracy. The accuracy increased by SNR levels, and we take the maximum for 15 decibel if we have audio noise, and 10 decibel if we have visual and radar noise. And this is for all my presentation. Thank you so much for listening, and I hope you enjoyed these results.
Thank you very much for that, Dr. Ghadban. Maybe I will start with a question again then. So you use radar technology. Have you thought about using LiDAR as well?
Sorry?
LiDAR technology too. So things like these are getting cheaper. You can find LiDAR in people's smartphones now.
Yeah, we can integrate these sensors. Also, it's just only one step to have more than 2 sensors, audio visual. So it's a good idea. Thank you. Yeah.
Thank you very much for your nice presentation. So you use multimodal data for voice recognition. My question is that when you extracted the features, in particular with radar, what features did you extract? I mean, if you don't extract the features manually or you use CNN methods that model itself extract these features, have you done any analysis on that?
We use these methods to extract these features, and these methods told you that this is, for example, 500 features that is important to you to train your system. Yeah, but when we use feature selection, we reduce this, which is the most important. For example, these features for visual, you can crop for just only the mouse or maybe or your face. These features doesn't matter to training. You want, for example, just only the lips. So feature extraction tell you which is the most important features you want to use it. That question is, yeah? No?
Yeah, I will speak with you in the break.
Okay.
Thank you.
Thank you.
Thank you for your talk. It's an interesting one. I have last 2 questions. So the first one is you are working on the multimodal system. So it means you're doing the fusion. So you have different techniques, the early and the late fusion. I wonder if you have considered that which technique of fusion you have used, the early fusion or the latter one. And the second question is, when you implement it in a practical way, I know it's not something related to the talk, how would it look like? It would be some kind of the Facebook Ray-Ban glasses with a camera and the hearing aid connected to the potential person, or how it would look like. Thank you very much.
Okay, I will start with the first question. Okay, I applied both, but I see that the early stage is more accurate. So this is the first question. I applied both, but here are the results for early. And the other question, if you can repeat it.
Yeah, so it was about the practical implementation of this research work. In my imagination, it could be like wearing a glasses and with a camera in the front to visually read the lips of the person or the overall facial expression for understanding what the person is talking about with embedded radar sensor in the glasses. I'm not expert in the radar. I don't know how big is that. Usually it's very big in the army setup. but I don't know how it would work in your case. And then it would be connected to the hearing aid somewhere, how it will look like. I know it's not related to you. Thank
This
you.
figure just only imagines that how can we apply our system. But in my case, I used my laptop and I plugged the radar and camera. So just only imagine that we can, the next step, make it like
Yeah, that's fine.
glasses and put the
No,
camera and radar.
thank you very much.
Thank you.
How did you pick the 10 words? Are they categorized into like the sounds? And do you know if a particular sensor was better at picking up a particular word or set of sounds?
This words is from this article, and I used just only 10 words to make it rich, because any speech recognition based on the data sets that we collect. So I tried to make it rich in phonemes and see that the most hard words, how can you recognize it here? Thank you.
I will do Valentina. Do you, Les, since you're organizer.
Thank you. Sorry, I really like your presentation, but I deal with completely different types of data. So what does the radar capture in terms of like the speech? Is it the audio or?
No, it's a signal. Detect the movements in front of you. It's not just only for lips. We can use it for activity monitoring, for, as I referred, daily activity. But I use this radar to help me to increase the accuracy and overcome the limitations of audio and visual speech recognition systems.
Oh, that's very nice. Thank you so much.
Okay, thank you.
Maybe a few more questions, because you're starting to get interrogated here.
If I understood correctly, you were training on 6-second acquisitions. And I'm just a bit confused. If you have a 6-second audio signal, if I remember correctly, your feature size was something like 300 or something?
Yeah.
So are you downsampling the audio signal so that you make a measurement every 200 milliseconds?
Yeah, absolutely. In speech recognition, we have to make downsampling, and we will use MFCC, so it's important to downsampling.
Okay. And do you also just use one picture? Because I think one of them was 784, which seems like a 28 by 28 image downsample. For the video feed.
For the video, yeah.
Did you downsample the video to just have a picture, or what did that look like?
I also use feature. You mean the feature selection, or before that we can take the frames?
When there was a slide where you compared your initial features and then the features afterwards, and I'm just a bit confused by what the inputs are. Yeah,
This one. This one, yeah.
Yeah. So do you take, for example, the audio file, the 6-second audio file, and then which is 837?
Yeah.
So that's how many amplitude, like audio amplitude samples there are?
Yeah, this is for
audio. It's 243.
Yeah.
Okay.
This is for audio. This is for video. This is for radar. This is the numbers of audio video, and this is for audio video radar.
So I'm just wondering how this works. Like 6 seconds of video, for example, how is it only 837 dimensional? It seems.
Yeah, this for one word. Yeah.
Yeah, but a 6-second video, if you have 30 FPS, that's 180 frames. One image is.
Yeah.
This is after the.
Yeah, after that is not, yeah.
Okay.
This also here, and after all these steps.
I see.
Yeah. No worries. Okay.
Okay, maybe we'll stop there in the
Okay.
interest of time. Thank you again for
Thank
that.
you. Thank you so much. Thank you for that.